All right, so this question here, or the first question that was on this packet, I'm not going to read through it here, but this was from 2002. So you could look up the scoring guidelines here for this one to see the breakdown of all the points and everything like that. But I'm just going to go through all these problems, all these steps here, or all these part A, B, and C. So here's the diagram that they have drawn for us here. I'm not going to read through this. We have some important information. We have some important information in here that we need to know. I'll just underline that here. So we have ship A is traveling at 15 kilometers an hour. We have ship B is traveling at 10 kilometers an hour. X is the distance between ship A and the lighthouse. Yeah, so let's just go through. First of all, we want to find the distance in kilometers between ship A and ship B. So if we just label that side over there, I don't know, side Z or whatever, just pick a variable. We just need to go through and find that. Now, we know that X is 4 and Y is 3. So, I mean, that should be pretty obvious that that other side is 5. But if you're not sure, basically we're just going to do 3 squared plus 4 squared equals z squared. Just use your Pythagorean theorem. That is a very basic, straightforward question. But basically when you do that, you just get z is equal to 5 kilometers. And again, make sure you have the units there. You want to make sure you always have units whenever they're given to you. So that's part A. Again, very straightforward problem. Part B. Again, important information. 15 is our rate. 10 is our rate. 15 is the rate for X. 10 is the rate. I should have had that triangle drawn over here again. So this was X. Let me come back here because this was ship A. This was ship B. So this is going to be Y. There we go. Okay. Find the rate of change in kilometers per hour for the distance between the two ships. So basically, x squared plus y squared is equal to z squared. So go through and take your derivative. So 2x dx dt plus 2y dy dt equals to z dz dt. Now, in the interest of time, when I do these problems, and when you do enough of them, and maybe you've done enough of them already, when I do them on my own, I don't even include the 2's anymore because I know that they're all going to cancel out anyway, so I don't even include them if I know they're all going to cancel out. So in the interest of time, if you're doing that as well, but you want to be cautious that you don't cancel them out if they don't cancel out. So, that's up to you if you want to get rid of them before you do the problem, or if you want to just save them and do them later. That's entirely up to you. So anyway, we know that x is 4. And then dx dt was the distance, the rate that the ship was traveling toward the lighthouse. So that should be a negative. If they're going towards the lighthouse, that should be a negative value there. Okay, so that one should be a negative value, negative 15. Plus y was 3. dy dt is the rate that B is moving, so that is 10, equals z we know was 5, and dz dt is what we're trying to find now. We're trying to find out what is the rate that these two ships find the rate in kilometers per hour of the distance between the two ships. So we're trying to find that rate now. So 4 times negative 15 gives you negative 60, plus 3 times 10 is 30, equals 5 dz dt. So add those together, you get negative 30 equals 5 dz dt. divide that over, and we get that dz dt is equal to -6 kilometers per hour. And again, they tell you in the problem, when they ask you, they tell you in the problem what the unit should be. They say in kilometers per hour. So they're giving you the units there. You just have to make sure you attach them to your answer. Okay, so there's your work for that one. Try to fit it all on the page there. Okay? And the last one, we had talked about this one yesterday, the setup here, so I have my triangle back here again. Let theta be the angle shown in the figure. Find the rate of change, so now we're trying to find d theta dt in radians per hour when, same scenario, x is 4, y is 3, which also means that this value would be 5, but we actually don't need that value because we're not even going to use that in our problem now. So what we're going to do is, if we're looking at theta right here, we're using y and x, so that's opposite and adjacent. So the trig functions that use opposite and adjacent are tangent or cotangent, okay? Doesn't matter which one you use, I will use tangent because that's what we had talked about yesterday. So tangent of theta is equal to opposite over adjacent, or in this case, y over x. Now we got to take the derivative because we're trying to find the rate of change of theta. So the derivative of the left side, derivative of tangent is secant squared, I almost wrote an x, secant squared inside theta times the derivative of the inside, d theta dt, equals, and then when we do the derivative of the right hand side, excuse me, when we do the derivative of the right hand side, we need to do the quotient rule. So low x, d high, so dy dt, minus high, d low, dx dt. All of this is over the low squared. Okay? So earlier I said that we didn't need the hypotenuse. I lied, because we do need that for secant. I forgot we were doing a derivative there. So we will need that this is 5, because remember, secant is hypotenuse over adjacent. So we do need to know that secant of theta in this case is equal to 5 over 4, okay? Because it's 5 over x and this is 4 down here. So we do need to know that value. Okay? All right, so let's plug in some numbers here and see what we get for d theta dt. We know values for all the rest of these, so I'm just going to start plugging in some numbers here and see what we get here. So secant of theta is 5 over 4, so I have 5 over 4 squared d theta dt equals my right-hand side. Actually, let me slide that down a little bit so it doesn't run into my x squared. Equals, and then my right-hand side, x was 4 dy dt. What was dy dt? B was 10 minus y was 3, dx dt was my -15, and then x squared is 4 squared, so that's going to be 16. Okay? So let's plug in all our numbers, and then we can just go through. Now the calculus is over. This is where algebra picks up, and we can go through and solve this. Okay, so if you want to pause the video and go through and do that little bit of arithmetic there and just see what you get, you can go ahead and do that, see what you get. I will go ahead and do that here and see what I get. Hopefully it matches up with the answer. So we got 40 plus 45 over 16. I'm going to multiply by the reciprocal in this process here. So dt right side, I get an 85 over 16. Multiply by that reciprocal of this one here, so that's going to be 16 over 25, which kind of works out nice. These guys are gone. 85 and 25, I can divide a 5 out there. 85 divided by 5, it's going to give me a 17 over 25 divided by 5 is 5. I got 17 over 5 units radians per hour. Okay, so hopefully you got the same answer there. So anyway, that was the first problem there with those ships. So if you have any other questions or any other problems that you would like to see me go over, just let me know, and I can make another video later on today and send that out to you as well. But just let me know if you have any other questions.